equation, very simply, is any mathematical statement that has an equal sign in it. That's why it's called an equation, because there's an equal sign in it. So we're given an equation here, 2q plus 5 equals 13. And we're also given what is called a replacement set. And the replacement set we have is 2, 3, 4, 5, 6. And all a replacement set means is that we're going to replace the variable in this equation, which the variable in this case is q. We have 2q plus 5 equals 13. We're going to replace that q with 2, 3, 4, 5, and 6. And we're going to see which, if any, of those 5 digits, 2, 3, 4, 5, 6, create what is called a true statement, meaning whenever I replace the q with, let's say, 2, for example. So instead of 2q, let's do 2 times 2 plus 5. If I do 2 times 2 plus 5, do I get 13 as the answer? And in this case, it's no, because 2 times 2 is 4, and 4 plus 5 is not 13. So this creates what is called a false statement. What that means is that 2 is not in the solution set of this equation. Okay, so let's try the next one. Let's do 2 times, and then the next number in our replacement set is 3. So let's do 2 times 3 plus 5 equals 13. Does that create a true statement? Well, 2 times 3 is 6. And 6 plus 5, it turns out, also not equal to 13. That is false as well. So 3 is not in the solution set. Let's try 4. 2 times 4 plus 5 is 2 times 4 plus 5 equal to 13. Oh, whoops! Let me keep my colors consistent here. There we go. So 2 times 4 is 8. Is 8 plus 5 equal to 13? Yes, it is. This creates a true statement. So that means 4 is in the solution set. Now let's try 5. Is 2 times 5 plus 5 equal to 13? Well, 2 times 5 is 10. Is 10 plus 5 equal to 13? No, it's not. That's another false statement. Last number in our replacement set to check is 6. Is 2 times 6 plus 5 equal to 13? The answer again is no, because 2 times 6 is 12, and 12 plus 5 is not 13. So this also creates a false statement. You may be wondering, once we got to 4, couldn't we have stopped? Once we found 4 being a true statement, couldn't we have stopped? Didn't we know that 5 and 6 weren't going to work either? And the answer is, in this equation, yes. In this equation, yes, we did know that there was only going to be one answer. We'll talk a little bit later how you can see immediately how many answers an equation is going to have. But some equations will have multiple answers. So just because we find one that will work doesn't mean none of the others will work. But in this case, only one did work. So we say for our answer, the solution set is 4. And we put it in these curly, oh, that first one is ugly. These sort of curvy looking brackets here. The solution set is 4 is what we write for our answer.